Hi, my name is Louis and I'm from Shenzhen. I'm a ninth grader in Eagle School and I love math, clarinet, coding. I also love playing sports. I'm a member of both squash and water polo varsity team at Eagle School. I'm an active member of my community. At school, I'm part of the Big Brother program where I mentor a new student. Outside of the school, I have always been passionate about community service. Since I was young, my parents often brought me to participate in volunteer activities, helping people in need. This past summer, I volunteered several times at a nearby welfare center, spending time with children with physical or intellectual disabilities. I helped them with their studies, play the clarinet for them, and play games with them together. Through these experiences, I realized that many children with physical disabilities could benefit from assistive devices to support rehabilitation and even return to normal daily activities. This insight inspired me to explore ways to help people with limited mobility move more freely. So I decided to design an exoskeleton to support joint movement and reduce the pain kids might experience while walking. I shared my ideas with some friends, since we all play sports, so we all understood the value of being able to move. We started by considering what types of application and materials we should need. We used 3D modeling software to design the project and then 3D printed the various pieces that were connected to create the brace. We used an adhesive that melts and hardens to connect the pieces, and we put an angle measuring instrument on the front of the knees and two motors at the joint. We connected the microbit motherboard to the exoskeleton, and I was tasked with programming it since I have a background in computer science. I set the angle measurement as 0 and 1, 0 being a straight leg and 1 being bent. Then I used Mind Plus to program the motherboard to send power to the motors when the input was 1. The motors would help move the leg forward, taking pressure off the extremity and providing support while moving. Once the motors receive single 1, they activate. Then there's a 2-second gap before they return to their original position. The 2-second gap is based on the average time it takes for a person to take one stride. Through repeated experiments, I began to understand the struggles of limited mobilities. At the same time, creating something that could help others gave me a real sense of joy. This project showed me how technologies open new opportunities for people with disabilities. In the future, I want to keep working on technologies so that people with all abilities can experience the freedom, confidence, and the happiness that the sports have given me. Everyone deserves that chance, and I want to help make it possible.